Today's lesson is subtracting fractions with like denominators. So again, we're going to be dealing with fractions that have like denominators, which mean they have the same number on the bottom of the fraction. The objective today is I will use models in computation to subtract fractions with like denominators. So we're going to be doing the exact same thing that we did yesterday, except we're going to be dealing with subtraction problems. So we're going to do the following problem in our notes. It says that you use 4/6 of a sheet of construction paper to make decorations. How much of the sheet is left? Model with pictures and simplify if needed. From yesterday's lesson, we learned that simplify means that we're going to write the fraction in its smallest form using the greatest common factor. So let's first take the problem and use cubes. So C stands for circle the key numbers. So we're going to circle 4/6. There's no other key numbers. Now I'm going to underline the question which says how much of the sheet is left. I'm then going to box key math word left, use, both tell me that I'm going to subtract. Then I'm going to evaluate or eliminate any numbers that I don't need. Well, since I only have one number that I circled, I probably am going to use it, so there's nothing to eliminate. And I know that my math words tell me I'm going to subtract. So now I'm going to solve. So my picture shows a rectangle that's broken up into 6 because I'm dealing with the denominator of 6. So each piece is 1/6. So I'm starting with, altogether when I'm starting with a whole sheet of paper, which one whole is the same as writing 6/6. I then am going to use 4/6. So I'm going to cut up 1/6, 2/6, 3/6, 4/6. So I'm going to minus 4/6. Then I know that I have 1/6 left, 2/6 left. I have 2/6 left based off of my picture. I now need to simplify. So I'm going to simplify means you use the greatest common factor of both the numerator and the denominator. So if I look at 2, I know that the factors of 2 are 1 and 2, and I know that the factors of 6 are 1, 6, 2, and 3. If I look at it, I can see that 2 and 2 are the greatest common factor. So that means I'm going to divide both the top and the bottom by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. So my answer is in simplest form. So the next problem we're going to do in our notes, it says to show how to find the difference of 7/8 minus 3/8 using models and simplify your answer. Now in this case, I am starting with 7/8. So if I look at my picture, I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. So I am not starting with an entire whole. I'm not starting with 8/8. I'm only starting with 7/8. That's why there's only 7/8 here. I am then going to take away 3/8. So that means I'm going to cross off 3 of them, which leaves me with, if I look at, I have 1/8, 2/8, 3/8, 4/8. So my problem answer would be, so I have 7/8 minus 3/8. And when I counted, I had 4/8 left over. But now you need to make sure that you simplify your answer. So you need to first think about what are the factors of 4. The factors of 4 are 1 and 4 and 2. The factors of 8 are 1, 8, 2, and 4. So now I can see that 4 is my greatest common factor. So I'm going to divide both the top and the bottom by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So my answer in simplified form is 1/2. So now I'm going to show how to subtract fractions with like denominators without using a model. So the problem states Kwame wants to walk 8/10 of a mile to the park. He has already walked 5/10 of a mile. How much farther does he have to walk? Show without using a model and simplify if needed. So if I use cubes, my numbers I'm dealing with are 8/10 and 5/10 of a mile. The question states, how much farther does he have to walk? I then need to box any keywords. So how much farther and has already walked means now I can evaluate. I know that I'm going to subtract. So now I'm going to solve the problem. So first we're going to start with 8/10. Now this is because the entire walk is 8/10 of a mile. So this is the in all part. This is how much we have altogether, 8/10. He has already walked 5/10 of a mile, so that means we are going to subtract from our total 5/10. So this is what he has already walked, because we need to use that. We need to use that to subtract from our in all, which was 8/10. So now when instead of using a model, same thing as with adding fractions with like denominators, if the denominators are the same, so in this case we have 10 and 10. If the denominators are the same, you just subtract the numerators and keep the denominators the same. So I'm just going to subtract 8 minus 5, which is 3, and I'm going to keep the denominators the same. So 10, 10, so I'm going to keep it as 10. So this is the answer to our problem, which this is how much farther he has. So how much farther he has to walk. Now we need to think about if I can simplify this. So if I think about the factors of 3, which are 1 and 3, and the factors of 10 are 1, 10, 2, and 5, they do not have one in common besides 1, so we know that 3/10 is our final answer in simplified form. So now I'm going to try another one. The problem that we're going to do is 9/12. So make sure you're writing this in your notes. 9/12 minus 3/12. So since our denominators are the same, 12 and 12, all we need to do is subtract the numerators. So 9 minus 3 is 6. And we keep our denominator the same. So we're going to keep it as a 12. We're not going to change it. Now I need to make sure that I write this in simplest form. So if I look at 6 and factor out 6, 1, 6, 2, and 3 are the factors of 6. And for 12, I have 1, 12, 2, 6, 3, and 4. So if I look, I have 6 and 6. That's its greatest common factor. So now you're going to divide both the top and the bottom by the same number. So we're going to get 1/2 as my simplified answer.